Hello, my name is Andres Coropa, and this is my final presentation for Engineering 305. This is the overview of my project. I'm going to start with the ANOVA test, the chi-square test, bivariate analysis, Pareto chart, control charts, graph builder, linear multiple regression, logistic multinomial regression, time series, and design of experiment. After all of the slides that I'm going to show you, I'm going to do like a little demonstration in SassJump of how to do every single topic described in my presentation. So the ANOVA test. The ANOVA test, or analysis of variance, is a collection of statistical models used to analyze the differences among group means. The type of data used whenever we run an ANOVA test, we're comparing 3 or more means based on one factor or more. For these purposes, the ANOVA test have to be grouped in continuous columns and in nominal or ordinal columns. I will explain a little bit more when I'm doing the demonstration in Jump. But basically, what it says is that you have to have two types of columns: one with numerical data or continuous, and one with nominal or ordinal data, at least. So, like a brief interpretation of the ANOVA test is that you have to make sure that the p-value is lower than 0.05, because if the p-value is lower than 0.05, then we can conclude that there is a significant difference in the mean studied. Otherwise, we can conclude that there is not a significant difference in our study. So now I'm going to show you how to do this test in Jump. Okay, let me open Jump, and we're going to use the typing data table. So this is my table. So what it means is that, like, for example, in brand, we're using nominal, or in this case, it's categorical data. And we're basically making a study in 3 different brands: Regal, Speedy Type, and Worthomatic. And we're trying to determine if there is any difference between these 3 brands. And as we can see on the second column, we have the speed. And the speed is a continuous, it has continuous values because they are numerical, as we can see. So I'm going to run the test right now. Click on Analysis, fit Y by X. For the ANOVA, we're going to use continuous data and categorical. So my categorical data is going to go in my X factor, and my continuous data in my Y factor. Run the test. Here's our result. Now, if we click on the red button, it means ANOVA. Here's our analysis. So from this table, we can tell that there is a difference in our values. But let's see what the p-value says. Yep, according to our p-value, the p-value is lower than 0.05, which means that there is a significant difference in our study. And we also can tell it from the graph. Obviously, this speedy type brand is faster than the other two. And this will be like a good example for companies, because if a company wants to determine which one to promote the most, it will be this speedy type. You can make a lot of money out of telling the people which one is better. It's just like with iPhones and Androids. They spend a lot of money telling that this one is better in like the camera or any special feature. Well, I'm gonna go to the next test. Move on. Now the chi-square test. Description: The chi-square test is used to determine whether there is a significant difference between the expected frequencies and the observed frequencies in one or more categories. Type of data used: the chi-square test can be modeled using nominal or ordinal data with nominal or ordinal data. I'll explain it later in the demonstration. And no continuous data are used to model the test, except when when specifying frequencies. And basically interpretation, whenever the p-value is lower than 0.05, we can conclude that there is a significant difference in the comparisons. Otherwise, there is no significant difference in our study. Now let me pull up the jump file. Okay, let's jump. Let me pull up consumer preferences. And here's a study of people trying to buy something, and for our chi-square test, we're going to use whether the gender and the single status have any difference. So basically, if a male or female, if the rate of single and not single men or female are different between each other. So let me do a chi-square test. For the chi-square test, we're going to use nominal data or ordinal data and nominal or ordinal. For this particular case, categorical means that it is nominal. So gender, my X, single status, my Y and my X. So from this graph, we can see that there's like minimal difference. I can barely tell that there's a difference between female and male being single or not single. Let's see what's the p-value for this particular example. Yeah, so we can tell from the Pearson chi-square test probability. It says that it's way above 0.05, because here we have 0.8954. So there's no difference between the gender and their status, meaning being single or not single, as well from the graphic as I said before. Now let's move on to the next analysis, the bivariate analysis. Okay, so for the bivariate analysis, we can do a lot of things with it, because this is one of the simplest form of quantitative analysis. It involves the analysis of two variables, they have to be numerical, for the purpose of determining the empirical relationships between them. As stated before, it is used to determine empirical relationships between these variables, for example, scatter plots, regression analysis, among others. Now let me pull up jump again to show you what it means, because basically what we're trying to do here is we're like using two columns with numerical data, and we were just trying to see like what they have in common, or if we want to do a regression analysis, we want to predict using that data, or we want to see like if there is a trend, some like kind of things. I mean, a lot of things we can do on it. Let me pull up jump. Okay, so here we have jump, and let's use the football data. So here we have height, weight, fast, speed, neck, bench, squat, like a lot of statistics from many players. And for this particular case, we just want to see like the speed based on the fat of the player, the percentage of fat. So we're gonna do a bivariate analysis we're gonna predict the speed based on the percentage of fat. So we can see from this particular table fit the line, we use the fit line function right here, clicking on this red arrow. We can tell that we have a regression analysis here. So we can calculate the speed of a player based on the percentage of fat. And as well, and because we did regression analysis, we have a lot of factors here that I'm going to explain later. And from our p-value, because this is the analysis of variance from our ANOVA test, we can tell that there is a significant difference in between with the data that I'm using, speed and fat. So it's a good model for this particular case. Okay, so basically, yeah, as I said before, the bivariate analysis, we can use the bivariate analysis for a lot of things. But for this particular case, I'm doing it for a linear regression analysis or prediction. Well, now I will move on to the Pareto chart. And this is my Pareto chart slide. So, a brief description. It is a type of chart that contains both bars and a line graph, where individual values are represented in descending order by bars, and the cumulative total is represented by a line. I'll do a little more graphic when I show you how to do it in the jump. But for now, it's basically telling that you have you have a lot of defects which are categorical, and you want to see like what defect is affecting the most to your production, your manufacturing, or whatever you're doing. The purpose is to highlight the most important among a set of factors. In quality control, it often represents most common sources of defects, the highest occurring type of defect, or the most frequent reasons for customer complaints, and so on. So now let me show you how to do this in jump.